Hello. So, how's everyone doing here today? How are you? Uh, so this is the last week of community period, and next week we start the coding period. So, have to get ready for that. I think both of you are ready. I'm not sure, but this is like where you start coding, and we do weekly updates on your coding progress. I don't know, Raj, if you had an update for us.
Uh, Hello, am I audible?
Yes.
Okay, I'll just give. Is my screen visible?
Yes. Yes.
Okay, so for this week, I continued working on the presentation. Then I looked into methods for deploying the NISA models, and I could do it successfully via something called Cloudflare tunnels. Apart from that, I integrated the models in a sample web interface and I published this week's blogs. I'll just show you the demo. So, for example, if we consider this a sample model, a sample agent-based model. So this is the web visualization funnel. Now the problem is this is in my local host. So for deploying this, I just found this thing called Cloudflare tunnel. So when I, oh, so uh, just give me a minute. I'll have to switch my Wi-Fi. It doesn't work on my colleagues. Sorry, just a second.
So, as I said to Raj, this is the last week of community period, and we'll be moving into the coding period next week. All right. He's back. All right.
Am I-
Yeah.
Sorry, I had some Wi-Fi issues.
Okay.
Is my screen?
Yes, I can see your screen.
Yeah, so as I was saying, this is just a sample NISA model, and this is the web interface for it that NISA generates on itself. So I found this thing called Pitfalls tunnels. So what it basically does is now this is running on my local host on the port 852. So when I run this command, I basically I basically get this URL.
Okay.
So on which my NISA model is deployed now. So if we just wait for this to load, yeah. So the NISA model is deployed with just a single command. So I mean, even if you all can try this URL, it should open the model for you all.
Okay.
So this is I think this should be good for deploying the models. And I just made a very basic web interface just to test the integration. So using this iframe, I could. So suppose I'll just put the URL over here, and then coming back here, yeah. So now in the web interface, I have the model. So the UI may look a bit distorted as of now, but once I start developing, I can have multiple models in the same web page, probably one below other or beside each other. So I found the methods for deployment and I published this week's blogs.
Okay.
Yeah,
You have published or you will
that's
publish? Oh.
I have published the blogs. I
Okay.
think I posted them on Slack as
Oh, there we go. Okay. Yeah, I look forward to that.
well.
Can you bring it up or?
And yeah, one more thing. Apart from that, I'll just show you my screen. Yeah, this is my timeline for the May 29th to June 6th period.
Okay.
So actually, I'll be having my examinations in this period, May 29th to June 7th. So this weekend, I'll try to get this work done.
All right.
I'll try to get this work done in the weekend as I may not be available in the next week. So I'll try to get this work done in the weekend.
All right. Yeah, so you're
Yeah.
basically enumerating the models, setting up Django Flask. All right. And then, yeah, that's,
Yes.
let me know, yeah, if you have any problems or, like I said, we can extend the projects, I think, by a week or two. But, well, don't use that as the first resort. You try to work around it. I think it should be fine. Um, that looks good, yeah.
Yeah. Yeah.
All right. So Vrushali had her update. Let's see. So she had it in a doc here. Check my PowerPoint for feedback. So let's take a look here. This is her. Oh, she's got a slideshow. Did you want to give this presentation or show it to us, Vrushali, or? Okay. I don't know if your screen is still sharing. I guess not. It's probably. Or, let's see. So, Vrushali, do you want to present this, or do you want me to look at it, or?
Please check it out. I will present it tomorrow.
Okay. Yeah, let's take a look. Let me share my screen. Entire screen. Here we go. All right, so this is what Vrushali has. I guess she's going to present tomorrow. This is virtual reality project proposal. This is her talk for our. I had asked each of our interns to give a talk, like a short talk on this. So this is the talk. So this is nice. Virtual worlds bloom as reality fades into digital dreams. I have a nice motivating slide. Virtual reality is my name. Vrushali now in my hands. And then our organization, which is nice. Okay, so this is from one of the website things. That's good. And then I like the graphics. They're very nice. Types of realities, XR, AR, VR, MR. So this is mixed reality, virtual reality, augmented reality. You might want to put underneath, in quotes or in parentheses, what those are. When you use an acronym, you want to have the full name next to it so people know what it is. But I think in this case, people kind of know what it is. You can mention it in the talk as well. So what's VR? So virtual reality is a computer-generated simulation of a three-dimensional environment that can be interacted with using special electronic equipment, such as a headset or gloves. It allows users to experience a sense of presence in an artificial world, used for gaming, education, training, and entertainment purposes. So this is good. Then the table of contents, project requirements, goals, sneak peek, stages, our team. So this is sort of like the stages of evaluation for the project requirements. 8. So this is virtual reality distributed research. This is the ABM models, Gamma, ABMU, NetLogo, which we talked about last week. Brain VR, which is this Blender and Unity XR. Morris Water Maze, this is the experimental setup. The Brain VR is for modeling. I guess there was a brain model that we had. And then OpenWorm, which is Blender and Unity XR. So putting out these different things, these different sort of pieces of content or assets, and you can just enumerate the tools needed. So that's good. About the project, my plan is to create immersive environment for biological process, simulation of ABM model in NetLogo, interactive subject which will be conscious about its surroundings, Morris Water Maze experiment. Okay, so these are the three pieces, these are the three sets of assets that you propose. So the simulation of an ABM model, the immersive environment for biological processes, and the interactive subject. So these are just the three things that we talked about. And then the technologies, we have VR, which is the headset, Blender, which is the modeling tool to create the assets, Unity 3D XR, that's the graphics engine, ABM software, we have ABMU, Gamma, and then NetLogo, and then OpenGL, which is WebXR, so we can render these on the web as well. And then about the project, this is the Morris Water Maze. This is the flow of this experiment. So we have what assets are needed. So we have all these. Actually, this is creating assets, importing assets, and then make various versions that you can implement, and then assembling the application. So yeah, I think in the Morris Water Maze, this is Morris Gaze. I guess it's maze, but that you'll want to have you'll want to kind of plan out what it looks like, and then figure out what assets you need, like what objects you need to make in that environment, and then the different versions. I guess I don't know if it comes later, but it's definitely you want to build it for if you did a 360 video versus a standard 3D environment, that would have to be something you'd have to plan sort of at the beginning. But the 3D, creating a world of 3D objects, you can create that for different environments. So you can create that for the web versus a headset. Once you get those 3D objects up and running, then you can actually just modify it after that. So, depends on how, what end application you're using for this. Is going to determine how you implement this exactly. But we can deal with those details later. And this is the biological processes, an AR/VR application which is compatible with all the devices such as MetaQuest, WebXR. This will allow learners and researchers from around the world to access and interact with models. This will also incorporate haptic feedback for users to make it more interactive. So this is kind of one of the standard techniques that people use. Like people simulate a lot of things for surgery, and some of the techniques they use is manipulating tools like laparoscopes in the context of a body or something. But this is where you have this is what these images are, like a surgeon doing something to biological, like an organ or part of the body where they're planning a surgery. So that's what these images are. I would say that's one of the things we'd like to do is be able to explore different things, and maybe not, well, I guess it's probably a very similar way. You might have an organ or the brain, and you'd be able to explore that object. You'd be able to take find parts of it and either label it in the simulation or have people explore the object, and the label would pop up in the field of view so that people kind of can explore different parts of the object that you're simulating. So this is biological processes. Yeah, we'll have to work out the details of this more as we go through. This is the flow. There's a brain atlas you're using as an example. This is just from the proposal. So this is there's WebXR, AR 360 video. There's a haptic audio, VR, sort of multimodal interface. So these are the different possibilities. This is the project again, same way as before. And then this is the agent-based simulation. This is the third one where you have your first and third person perspective. This includes making ABM simulations using NetLogo and Gamma. So we talked about this where you would turn this into a three-dimensional or a virtual worlds application. And I'm not exactly sure how that would be implemented. I have kind of a vision. I don't know how hard it would be to implement. And that is to have this agent-based grid be a 3D space where you can see your agent in the distance or your fellow agents in the distance. It's also possible just to do the simulation as a two-dimensional thing, but that's less exciting. I mean, basically we'll have to work out the details of this. And if we don't want to spend the entire summer trying to perfect one little thing or trying to implement one little thing. So we'll have to figure out what's viable for the summer and then maybe figure out next steps later. So, maybe we do something for the summer, do a first step towards this, and then we get We have subsequent things we might do for another year or after the summer. So yeah, this is the agent-based model. So this is basically the idea that you're running an agent-based simulation, but it's in 3D or it's in a virtual world. So whether that be like a first-person perspective on the agent's world itself, or maybe being able to see this in different ways, this grid, it's not clear. But I mean, yeah, that's fine. We can figure that out. Whatever I think is easier to do. I don't want to like spend a lot of time going down like a technically hard path and then not have it pan out. So this is the flow of the application. This is the agent-based model. These are the two platforms. So I mean, we have like Gamma and we have NetLogo, and those are sort of in agent-based models. Those are the state of the art. So we'll probably have to work within what we can do with those platforms. And so, that's what we'll have to do. We have the physics simulation, so there's that. We have the actual ABM simulation, which is different than the rendering the objects and doing the 3D physics. And then we have to assemble the application, and I see the logic there. So why is this important? I think, this just kind of talks about why it might be important to do like something in VR versus something that's not in VR. And it contributes to research, and I'll talk about that in a minute, kind of what our roadmap is. I kind of came up with a roadmap for this, so we'll talk about that in a minute. And then deliverables, so we have these three things that are deliverables. And like I said, I think in this project, the deliverables are going to be a little bit more fluid because I'm not sure what's technically feasible. When the rubber hits the road, we'll have to figure out what is technically feasible, So, I mean, what I would suggest here is to start with one project or start with one of these three, put together something, and we can evaluate it and see what it looks like. And then we can suggest changes to it. Because otherwise we're going to be like nitpicking over like very tiny details and or we're going to go too big and start like working on everything at once and nothing will get done. So I would pick like one, either the Morris Water Maze, the biological simulation, or the agent-based model to start. We'll pick one of those. I don't know what order you think is most important, but I'll leave that actually up to you. Because I don't, all of these things are things we want, but I don't know which ones maybe we pick the low-hanging fruit first. So if you think the Morris Water Maze is the easiest, which I think it probably is, we can do that first, and we can put that together. So then, just put together something, mock something up, and then we can evaluate the mock-up. Don't worry about the technical details too much. Just get something that works. And this, holds true for Raj as well. Like, when you think about, like, what do you want to demo to the group to show that something is working? You don't want to perfect everything. You just want something that you can demonstrate. And then from the demo, we can actually work from there and say, this is something we want to keep. This is something we want to change. This is something that is working, and maybe we can add on to it. So that's how I would approach this. I don't want to force you to do anything that is going to be impossible to implement or very hard to implement. We want to start with the easiest things and then move to the more complicated things. So at least then by the end of the summer, we have something in place. And so the deliverables are these different models, the different components to them. And then, they're details like haptic feedback and sound effects almost might be secondary. And you could view that as like the thing that we might do after we get everything in place. So the simulations, the 3D objects, those are probably the most important things. Getting those kind of secured and, figuring out how that works. And then you can put in like feedback and sound effects and all this. But we have to start with this sort of design process where we put together something that is workable. The web interface, So this is going to be later, but we'll have to have some deliverable. I would like to, I think a WebGL interface, a web interface would be good to start with. The different platforms for virtual reality for XR, they're always changing. So, there are proprietary standards, like, there's the MetaQuest, there's, Apple's coming out of the headset. There are all these different proprietary standards. I'm not sure how to navigate those myself. So those are something we might not immediately do, but we want to have something that, you can view sort of more generally. I think the WebGL should work, having a standard like that. And then we can, maybe later on we can say, well, we want to create an application for this specific platform, like MetaQuest. We could put it into their store. But that comes later. That doesn't come right away. So I like the WebGL approach, just having it so that we can open it up. So in a headset, for example, you can open up a web browser and you can explore something in that web browser. It's not like, as good as like an actual application where you have like, the full space. But that sometimes that takes a lot of effort to put those together. Sometimes it's as much work getting those to, the usability aspect is perfecting that than it does like creating the assets. So, we're working within a summer. So I don't want to overwhelm you. I don't want to, I don't want to spend a lot of time on things that, we don't want to put the cart before the horse. So we want to work out these details of the simulation first and then work out those later. And then documentation. So yes, that's important to have, especially with something like this, because there are a lot of moving parts, and there's like, what is this thing that you've created? What is it supposed to be? And how do I use it? Those are important things to know, especially if you're if you put it in a repository and 6 months go by or a year goes by and people pick it up and they don't know what to do with it. So that's one thing we want to avoid, is that confusion. So yes, documentation is important. So the timeline, we have these different, you could work on the biological processes or the ABM or the Morris water maze. So these different, the timeline is, up to you exactly how you want to approach this. I would start with the lowest hanging for first. And if that means that you create something common to all of these, like some assets, like some 3D objects, and start creating those and putting them into an environment, that's fine. You might find that like some of these things will share components. So you might think about that, say, oh, okay, I can use this for both of these. So I'll just create an asset and then maybe modify it for one or the other. And so then you'll have those two things down. See, you're working from this very simple part where you're just creating a set of 3D objects, a little library of things, and then you're putting them in these different simulations. And so then that solves your problem. So the timeline, I think that's fine. It's kind of hard to know exactly what the timeline should be if you don't know what you have to kind of work through some of these things to see what the timeline actually is going to be. And I think, like I said, the best way to do it is to sort of make assets, mock something up, see what works. We can demo it in the group here. We can look at it and say, this looks good. Let's add more detail. Sometimes things don't work out in concept. And so that design process is a bit hard to, do on your own. You'll need to get feedback from us. And so that's what I'll have to say about that. The timeline, we'll keep on top of it. We'll try to not get hung up on anything. And, I know there are 3 different things here. So, I wouldn't necessarily, work on one, work on the other. I might just kind of work on one and, get to a certain stopping point and then say, okay, well, let me see if I can do some work with the Morris water maze experiment. What I want to avoid is basically jumping back and forth between 3 things and then getting nothing at the end of the summer, or getting half completed work. I want to kind of get to some nice endpoint where maybe we have a very simple thing we can show in VR. It's not what we wanted necessarily, but it's a nice simple version of something. So it might be a very simple biological process simulated or a very simple ABM, and it may not be the like first person view. It might just be like playing with ABMs in a headset. I don't think that's a that might be something interesting, but it's a start. We can say, okay, well, we can theoretically render some of these components in virtual reality because remember there is this aspect of like rendering things and getting things to work, and that's where we may have a lot of problems. So I wouldn't I wouldn't necessarily switch between all three, unless if you want to focus on one and then focus on another one. And like I said, in the application period, we might not get to all three of them this summer. That's probably okay. But I'll leave that up to you how you want to pace that. Then this is the timeline. Yeah, I think this, I think getting like very basic assets done, mock-ups, that's good. Even if you just want to do like mock-ups of all three and then present those and then see which one is most viable and then work from there, that would work too. And so yeah, we want to work from very simple, getting things in place, and then adding in like the details, controllers, other details. And so yeah, and then the evaluations, so it's nice to have goals for the evaluations. The way I deal with evaluations is very much informal. If you're working hard, I usually say, okay, that's great, and then I'll give you feedback based on where we are. So it's not like you're going to fail it because you don't do enough. It's just that like if people don't show up and you don't hear from them, I have failed them. But otherwise, it's usually pretty simple. But yeah, these are nice goals to have by the evaluation period. And then, going through. Okay, so that's great. And then this is a nice little poem here. Yeah, it's great. Join us now and play your part. So this is great stuff. This is a nice presentation. I like this a lot. Looks like you have some extra slides here. There's Jesse and myself. So yeah, good job, Vrushali. Thank you for that. Yeah, and you said you would present that tomorrow in tomorrow's meeting. Yes, okay. Yeah, I look forward to it. So yeah, I think that's good. And so yeah, so this is the end of the community period. We've come to the end. I guess it's just, the whole point of community period is to engage with the community, learn about it, see where, your work fits into that. I think you've done that. And, I don't know if you have any more questions about the community or anything, but will you have anything? I don't know if Raj wanted to say something. But you're muted.
It was a really good time this year. We got very comfortable with the organization and all that. So yeah, it was good. I look forward to start the coding session now.
Okay, yeah. So yeah, good. And so next week we start the coding period, and if you have exams, we can work around those. We can extend the coding period by a few weeks. I have to contact INCF to do that. I would not do that as a first resort though. If we get closer to the end and we see that we need that time, we can request it. But otherwise, we can try to work around it. So yeah, and like the coding period is, don't get overwhelmed about the schedule. Like I said, we can work the schedule out. You'll likely have to rescope your projects a bit because especially like for Vrushali, because you'll run into like technical difficulties. You'll see that some things are easier than you thought, some things are harder than you thought, and so that's not like a problem. We can always like just move things around on the schedule and keep working on things, and then get to the point where we have, by the end of the summer, we want to have something that we can, run, basically an executable of something. So whether that be like an implemented web interface or an implemented 3D environment of some type, we want to have something like that. And, not to say that you can't do more than that, but like we want to at least have that down before we end. Because, just having like all this work, it's nice, but it's like, you have to show it off some point. And so if you end the summer and you never come back to your project, you'll at least have that, say, for a portfolio. You'll have your GSoC project, you'll say, this is it, I can run it for you. I can demo it. And so then you can see how it works. And in past years, I've had people do models like, the Bradenburg vehicle models, the ABMs, and every summer, the people who finish their projects, they have something that they can execute and you can use it. It's not perfect, but, that's something we can actually do in the group. As an open source project, we can go back and people can, in future years can modify it, improve upon it. But having that thing that runs and that runs in a decent way, like you have documentation, tells you how to run it. It can run and give you some results of some type or be functional. That's what you basically want. And then we can work from there. You can improve it later. I had one person who worked on his project and he had it running and then he's improved it since. It was Ankit Gupta, who's done a lot of stuff with, he did some things with Bradenburg vehicles, collectives. So there are these Bradenburg vehicles that form collective behaviors. And he's been working on that for a couple years now. And he's improved quite a bit since the GSoC period, in which he was working on implementing it. So, open source software is like that. You can have like an open source platform and, you have it where people can access not only the runtime stuff, but the code and the documentation, and they can add to it. Or you can add to it later and release it and say, this is the new release, this is what's changed. And, okay, yeah. So Vrushali said she'll post her blog by the end of the community period. Oops. So, yeah. So thank you again for participating in community period. I look forward to seeing both of your blog posts. Actually, you can post it in the Slack channel when you're done with that. And so, yeah, we should do that every week, actually, if you have a blog post that you've made, to post it in the Slack channel. And, like, the blog posts at this point should just be, like, aside from the community period stuff, they should just be technical updates. And that can help you with your documentation. So you'll use that as, like, the basis for that. So, okay. So that's all I have to talk about in terms of the community period. So we had a couple things I wanted to go over. First is that speaking of I think it was last year's GSoC, and last fall we did a project related to last year's GSoC. It was on the agent-based models for open source sustainability. And next week we're going to be, I actually have finished a 20-minute presentation to give to a conference called Sustainable AI, and they're located in Germany, but it's going to be a virtual conference. And I wanted to go over those slides really quickly. I'm not going to give the whole talk, but I'm going to record the talk and put it on our YouTube channel so people can see it. But I wanted to, actually that's the wrong one. I wanted to go through it really quickly just to show kind of what we've been doing. So we have this open source sustainability project, and the way that I'm presenting this to the group, so these are all our participants from last year. Jesse is here, Brian McCorkle, Hussein Ather, and Himanshu Shogul. And these three people were GSoC people from last year. And of course, Jesse and myself are mentors, supervisors of this. So we kind of took these three models that were created, we put it into this sort of cybernetic approach we're couching in terms of a cybernetic approach. Basically, how do you keep open source communities both active and encourage virtuous behaviors? There are a lot of different platforms that people have proposed. We have a preprint on this where we talk about these different things that people have created. They measure different things in the community, like the number of commits or whatever. Then, what we're doing now, what we're interested in is focusing and optimizing the endpoint of the community, which is contributions. These platforms do that well, but there's more to it than that. And so, how do we sort of take these contributions and take the whole idea of working open, not just like the different open source activities, but other related activities, and take those into account to build a model of a self-sustaining community. And so this just kind of shows all the aspects of open source. There's governance, open access publishing, usability and data analysis, different things. And so we have these three models. We worked these models out last summer and last fall, and we did this, in an interactive way. So this is the outcome. This is the repo that we've created with the models in it. And so we use active inference as one source of inspiration for one of our models. That was the one that Brian created. He was interested in collective active inference or collective decision making. And, he's using this POMDP model, which is a Markov decision process, partially observable Markov decision process. And basically it's agents in an environment where they know what the other agents are thinking. And so they try to align their beliefs with each other. And so this is important because when you're in an open source community, you're aligning your objectives with each other. And if you can do that successfully, then you can work on projects seamlessly. If you can't do that, then you have a lot of problems with aligning your goals, your values, and things like that. So this is a way to do this, a very computational view of this, where you're trying to maximize the trade-off for each agent using a free energy function. You're trying to maximize your payoff with respect to involvement. And then, you have this belief aspect where you use Bayesian inference to update your beliefs about what's going on in the community, what other people are thinking, and you try to align all those across the agents. So this is the belief distribution over time, which converges to a single belief. And then this is the model where you have the single agent as an architecture. They sense the environment. They have these internal belief states. They try to target like a certain belief based on what they see other agents doing. And that's, just basically behavioral alignment. So kind of go through the details of that. And then the second model, this we have an OSDC model, which is the open source development community model, which is specific to open source community development. So the general model is the computational model that Brian kind of put together, and then he specified it for open source communities. This helps us, this is particularly well suited to mediating things like the free rider problem, which is where people kind of benefit to the system without contributing. So, people might use the software a lot, but not contribute to its upkeep. And we want to avoid that. So we can use this model to sort of figure out how to avoid that. And so then the second one was actually Himanshu. He did this multi-agent reinforcement learning model, which is it's an agent-based model, but it uses multi-agent reinforcement learning to sort of drive these different behaviors. So this is an example of multi-agent reinforcement learning as a simulation, an agent-based simulation. There's this architecture where the agent, the community participant, observes their environment. They find the things the policies at work, the community experiences, or interactions with other people. The agent then reinforces those, and those become the things that they have in their the policies that they follow. So, you observe your fellow community participants, you see what they're doing, you see what's beneficial, and then you do those things. So it's reinforcing what's in the community. We use Q-Learning as this community building guide So, you look at the differences over time. What's the maximal value of a learned behavior when compared with the current behavior? And, there's a learning rate, so we can actually see how quickly people adopt things in the community. So we have these different ABMs that are, we can run these simulations, and then there's cybernetic big five theory, which is something that Hussein worked on, and this is where you're taking personalities of different agents and you're modeling them as positive or negative interactions, and works basically in a similar way as reinforcement learning. You reinforce the good interactions, you repel from the bad interactions, but this is in a personality view, so it's not the virtuous behavior so much or the things that are the highest payoff. It's whether or not people's personalities are similar or not. And so that tells you if individuals of a certain personality can work together. And so this is a little bit different way of doing this. So kind of go through some of these aspects of future directions and how to link this with cybernetics, which we didn't get to last summer as much, but it kind of works out some of these details. And then we have our sustainability auditing tool. I'm going to mention it very briefly. And I think actually the abstract was about the auditing tool, but I figured we can't do that really right now. So that was that talk. I'm going to try to compress that into 20 minutes of content and put that on the YouTube channel. So that's going to be at a conference coming up this week. Oops. The next thing I wanted to talk about, this is for Vrushali's benefit. It looks like Jesse had to leave. Is the VR roadmap. So you gave a very good presentation on VR. Thank you. And then you asked in the Slack if we had a roadmap. And I said, well, last week actually, you said, did we have a roadmap? I said, well, I'll come up with something. And then you said you weren't sure about things that were, it looks like you have a pretty good handle on it, but I wanted to go over maybe our roadmap a little bit to show what my vision is for what we want to do with VR. So it looks like Jesse had to leave. Yeah, it's fine. Thank you, Jesse, for attending. So we do have a roadmap. I put this together based on sort of what I was talking about last week. So we have these three buckets. We have science research, we have education, and we have working open. And I don't really have a timeline on the roadmap. That I don't think we're there yet. But I want to give it like an overview of what we're thinking about in each category. So we have the science and research category, which is a number of things. It could be visualizing a scientific problem. So like Vrushali talked about, biological systems like the brain, being able to visualize something like that and put labels on parts. And, that has overlap with education, but it's also, visualizing things that we might be interested in exploring. So some of that may be the Morris Water Maze, where we want to see, what behavior looks like in a certain environment. Basically anything we can simulate to get a better understanding of it as a process or as an object with a geometry. One of the things we suffer from in our virtual groups is that we don't have shared access to things beyond our two-dimensional faces. So I can see myself on the screen here, but that's two-dimensional. You've never seen me in 3 dimensions. And I don't know if you want to, but I'm a 3-dimensional character. So, but we can actually show objects in 3 dimensions and share them across people. So if you're in India and I'm in North America, I can share an object with you, and you can explore it. We also have human augmentation. So sometimes you can use VR to augment your capabilities, or augmented reality, AR. You can use that to augment what you're doing. So you can use it to improve your performance on things. You can use it for training. You can, like flight simulators are good for training. You can improve your performance on a real-world task by using the simulation. And then there's ecological and spatial cognition. And in this bucket, I put in the Morris Water Maze because you can actually explore an environment through spatial cognition, ecological. There's also ecological perception, which we're interested in the group, and that is where you experience these environments. You experience objects coming towards you or moving away from you. And from that, we can actually create situations where we can measure people's ability to see things, to do continuous perception and things like that. So that's science and research. Then there's this education bucket, which involves like classrooms and discussion and interactive demos. So we can create demos for things, and you're going to be doing that over the summer. But more generally, we like for people to be able to. We kind of want to see how it is to learn how to use some of these assets. So one of the things that Vrushali will be doing is working with Unity and things like that, and she'll be making documentation on how to use it. And so, in that sense, we can pass that on to other people so they can make their own demos, so they can show something in a world, and in a 3D world, they can show a concept that they have. They can mock it up and show it to us. I also have a video on the YouTube channel where we have classrooms and discussion, where we can sit in a classroom and I can show something on the board and we can share that experience. So we can do that for education. Finally, we can do things like working open. And I have some videos on the YouTube channel about this where we can have a meeting space, we can do our meetings, but we can do those in 3D instead of 2D. So in Jitsi, we do it in 2D. We have our little squares. In VR, we have 3D, an opportunity for that, where we can, touch each other's hand, avatar to avatar. We can have physical interactions. We can, show things on a board. We can show things in three-dimensional space. So that's something that we can do as well. So, right now I think Vrushali's focus is in these two areas, science and research and education. And I don't want to overwhelm you with this, but that's where your work is going to fit in, mainly these two buckets. And so this is just a very long-term view. I don't want to say that we need to do all this summer. I just want you to be aware of where you're putting your efforts into those buckets. And so whatever you can do to move that forward would be great. Yeah. So do we have any questions about that, or? Oh yeah, no problem. Yeah, I just wanted to show that just to give us an appreciation where we are. Finally, I wanted to talk about this paper that came out. This is another VR thing, but I think it fits into this roadmap idea. So this is something, I think I posted it in the Slack. I'm not sure if it's I think it is in the Google Summer of Code channel. And this is a comment in, I think, Nature Human Behavior. So this is a pretty decent journal. The three people, Peter Schiffer, Da-Shun Wang, and Diego Gomez-Zara. And basically what they're arguing is, so if you go to this roadmap, you'll see that there's science and research. And you have these different things around science and research. And their focus is on using the metaverse for science. So, you can use the metaverse for education. You can use it for working. You can use it for other things. They're focused on how to use it for science. And so this is the promise and pitfalls of this. So people write these articles every once in a while, and they're very timely. Like, me and my colleagues wrote a paper about 10 years ago or more now on how to use VR for research, for medical research, for psychological research. And there's a lot of stuff there. But, that article is like 10 years old in terms of the technology. So it's good not to focus just on the technology because it's always changing. Okay, so in this paper we have just kind of a perspective on what this is. The metaverse can improve the accessibility of scientific laboratories and meetings, aid in reproducibility efforts, which means that you can use VR to create an environment that's constant across different contexts. So someone can pick up your like experimental stimuli, like you can pick up a Morris water maze, a virtual Morris water maze. You can use it from laboratory to laboratory, and it's always the same. It'll give you the same outputs. And so that's important when you run experiments because you want to make everything sort of uniform. And so you can aid in reproducibility using these kind of platforms and provide new opportunities for experimental design. So we would work on like an experimental design this summer that would help like have that asset, but it will help us think about how to do this in the future. So there are a lot of experiments that we might design, psychology experiments or behavioral experiments where you want to design them in different ways. And sometimes you can't do them without VR. So if I wanted to design an experiment where I was navigating through a maze, I can't really do that like virtually without VR. I may not even be able to do that in a physical room because I can't measure the outputs. So this helps you with this. But what their caveat here is that researchers and research institutions must plan ahead and be ready to mitigate potential harms. And so what they're talking about here is how virtual reality is great. It's allowed us to do remote work, remote, investigations. It, helps you do a lot of things. There are a lot of different technologies that are associated with it. And so there's this potential, but, we have to define the metaverse. Their definition is as an immersive and persistent 3D environment in which people synchronously interact with others, with virtual agents and objects, and with representations of objects in the physical world. And so that has three components. The first is the metaverse enables interactions with both digital environments and physical objects located in different places, all within an immersive environment that is persistent through time. The metaverse also enables individuals to interact with other people in remote locations. And third, by incorporating concepts such as the Internet of Things and digital twins. And I'm going to talk about some of these tomorrow in the meeting. We have, there's some interesting work being done on that. The metaverse enables objects manipulated in virtual reality to cause effects in the physical world. So you can actually model yourself as a digital twin or map some of your controls to an object in the environment, like a robot, and you can manipulate the world through a virtual mediation. So these are things that you can all, this is why the metaverse is useful. These have increased in the last 10 years, I would say, especially with respect to the Internet of Things and digital twins. But, those things are kind of always moving forward. So, it allows for greater accessibility. It allows for us to break down the boundaries of geography. It allows us to break down the boundaries of the physical. When we have these two-dimensional screens, it kind of limits our ability to interact in that what Vrushali mentioned is presence. We don't have as great a presence when we see people in 2D, but when we see, even if we see their avatars in 3D, that's better. That gives us a greater sense of presence, or that you're in the room with the person. Oh yeah, I'll share that article. I'll put it in the chat. So there are opportunities for science. There's accessibility, reproducibility. Reproducibility, again, is where you create an environment that is sort of constant from researcher to researcher, or constant every time you run the experiment. And so in 3D simulations, you can use like a virtual machine to make sure that the thing always runs at the same speed. And then you can, in different laboratories, you can run these simulations, and they're all basically the same. There's uniformity in how they're delivered. So then you can actually look at the results and say that the variation is due to people's behavior rather than just, whether the environment was set up correctly. So there's a reproducibility benefit. There's a training and learning benefit. So like as I mentioned, sometimes you can do things like train people to fly a plane in a virtual environment, and they can actually pick up those skills and use them in the real world. So if you train people on you can also do a lot of training on anatomy and learning of what's in the human body. So, you can explore a model of the human body. You can look, inside of it. You can get different perspectives, and it helps people learn what those anatomical parts are and how to identify them. And so all these things they call this transfer of training, where you can transfer your training from a virtual model to the real world. And so that's another benefit here. You can also do things like teleoperations. So the Curiosity rover on Mars, we can control that from Earth. And that involves basically building a virtual model of the rover, of the planet that we have in front of us, and controlling the rover. And we create a virtual representation of Mars, and we create a virtual representation of the control, so that the Curiosity rover doesn't fall into a ditch, because we know that there's a latency between our signal that we send and what the rover is doing on Mars. So we want to make sure that it doesn't fall into a ditch in between the time we send a command and the time it receives it and moves. So we have to model these things, but we can do this sort of teleoperation, and it's been successful because the Curiosity rover has done a lot of impressive things. So these are things that we can do as well. So there are a lot of challenges. There's this future aspect where there's probably going to be some sort of regulation. There's policy that needs to be designed around this. There's also, there are other types of problems with technical aspects. You have things like health issues. Sometimes people get sick in virtual environments when you deliver the stimuli in the wrong way. There are privacy issues, surveillance issues. This kind of goes into our theme on tech ethics. So we might talk about that in another context, about privacy and surveillance aspects of this technology. There's actually getting the technology. So, headsets have been very expensive until quite recently. There's still several $100s to get a decent headset. So having access to the technology may be a little bit difficult for people. So we have to keep that in mind. That's one of the reasons why I want to create an open set of tools so that we can share them across, physical locations with minimal investment. I don't want people to have to spend thousands of dollars on these things. I want to be able to do these things rather cheaply and accessibly. And then there's code fidelity, which is where you have you need to be able to have a consensus on how to model things. So there are all sorts of standards for modeling and things like that. There's metadata. These are things, when you talk about reproducibility, you talk about a lot of the benefits of VR. Code fidelity is one of those things that I think probably can drive that forward, because you can get standards put in place. You have standard, pieces of code for different assets, and those assets will behave in the same way from, environment to environment. You don't want to create custom code that you don't know exactly what it is, and then someone else creates something that looks similar but isn't. There are just, a lot of issues like that crop up. And then, so this is just kind of a forward-thinking paper. They give a lot of these potential challenges, and we can talk about this in future meetings. I just wanted to provide this as a way to sort of think about these things going forward. So I'll put that paper in the Slack, and this paper is in the Slack in our Google Summer of Code channel. So, okay, thank you, Vrushali. So that's all I have for today. We have any questions? Okay. Well, good luck with the beginning. Oh, we do have repos that I wanted to give you access to. So let me see if I can get this link. I do have a repo. Actually, let me share my screen to show you where the repos are. I have them on our GitHub repository for the organization. So if you go to the ORL group GitHub, github.com/ORL group, and there's a GSoC repository, and there's a directory 2023, and this is where I want people to like push things or to put things, archive things as appropriate. I don't know your personal preference in terms of working, but it would be nice if you could fork GSoC, this repository, and then update this part of the fork, like these two. So I have open source sustainability, which is this directory, and I have virtual reality for research. And so one of the things that would be beneficial is that every week we could make a push to that, push your fork. So you fork this GSoC repository, you work in this repository here, this directory, you post your files, you have your documentation, so you don't have it on your local computer. And then you're going to make a pull request, you're going to push your updates once a week, hopefully, and then it can be accepted. And then in the meeting, we can just open this up and say, this is what we did for the week. So, I want to make sure that we do that. I can put the link in the channel as well to make sure that we have access to that. That's my preferred way of working on it. If you prefer having your own repository and then updating everything, at the end of the summer, we want to have this archived in this place. That's basically it. So if you have your own repo, we want to be able to move that over at the end of the summer, or it's just easier to work from this fork. So I'll leave that up to you how you want to handle that. But we will review the code in GitHub every week. So I want to be able to have that we can just go right there and see it. All right, well, thank you. Have a good rest of your day.